Welcome to lesson 2 of remote learning. And today we're going to be focusing mainly on compound interest. As you learned yesterday, it really is the best way for your money to grow. And if you're talking about an investment, it's the best way for an investment to grow. If you're talking about debt, yeah, that's a different story. First, I want you guys to do this question. This is the do it now, where you're comparing simple interest versus compound interest. I'm going to go ahead and pause my recording. I want you guys to fill in the table and we'll check our answers here in just a few moments. So here is the comparison between simple interest and compound interest. And I'm not sure which of the first of you was to notice that my spelling was wrong there, but compound obviously needs to be spelled properly. For the simple interest, principal plus principal times rate times time gives me $23,000. A couple of you guys were asking the question about turning a percent into a decimal, and this 3%, if you divide by 100, gives you the 0.03. So just a quick refresher of that because I didn't do that yesterday. The compound interest, you can see here we started with 20,000, still 3% interest, and we are doing this for 5 years. At the end of the first year, an additional $600 has been added to my principal. So now I have 20,600. To shorten mine up a little bit, I just took the amount of the 20,600 and multiplied it by 1.03. You're going to get 100% of your principal back plus the 3%. So that's 103% that you end up with at the end of that year. And then as a comparison, if you guys just quickly check 23,000 compared to 23,185 and 49 cents, the compound interest grew quicker, and that's what you'd want to happen to your money. Now, some of you might be asking yourself, is there an easier way of doing compound interest instead of doing these tables? And you're in luck because the answer is yes. Of course, true to form, we teach you the kind of the long way and then the quick way as a comparison here. Your compound interest formula is the amount is equal to the principal, and then in brackets, 1 plus I is interest rate. So that's the 1 plus 3%, 5%, 7%, whatever your interest rate is for your different investment or debt. And N stands for the number of compounding periods. This table right here is going to be really important that you check as you are doing your formulas. Annually means one time a year. So that means you don't have to do anything to the interest rate, anything to the term or the investment period. Semi-annually, 2 times a year. So you will have to divide your interest rate by 2 and multiply your term rate by 2. And I'll explain why that is as we get doing some calculations. Quarterly, that means 4 times a year. You'll divide your interest rate by 4, but multiply your term by 4. And then last, typical compounding period would be monthly. So that's 12 times a year. You'll divide the interest rate by 12 and multiply the term by 12. Occasionally, you will find a compounding period daily. This tends to be debt, not investment. And so if you see a daily amount, you will need to divide your interest rate by 365 and multiply your term by 365. That's a pretty rare situation to see. Again, A stands for amount, total amount. P stands for the principal that's being invested. I is interest rate. And N is the term. So let's see how this works. Just recopy my formula here. So you're going to copy down your A equals P 1 plus I to the power of N. It says determine how much money you'll have if $500 is invested for 6 years at 4% per year, compounded semi-annually. So the key word here is semi-annually. You have your principal amount, you have your interest rate, and then you have your term semi-annually. So before I even do anything with my formula, I'm going to take my interest rate, the 4%, and semi-annually means divide my interest rate by 2. So 0.4 divided by 2 is now going to give me 0.02. And I'm going to hold on to that number for just a minute. My N value is take your term and multiply that by 2. So 6 years is my term, multiplied by 2 gives me a value of 12. So when I go back to my formula, A equals principal, $500, in your, oh, I put an I there, 1 plus I, 1 plus I, so 1 plus I is 0.02 based on the 4% divided by 2, and to the power of n we calculated as 12. So what the banks will do is they'll take your interest rate, and if they're compounding your interest semi-annually, then they're taking your interest rate and they're giving you half of that amount. Sorry, quick glitch there. Half of that amount twice a year. So the 2% is they took the 4 and they divided by 2 because of the semi-annually. And then if you consider the fact that in 6 years, they're going to give you your interest rate probably January and June, or June, December kind of thing, twice a year. So 6 years, twice a year, they're going to give you your interest 12 times during the length of that investment. So quickly grab your calculator there. We're going to see what our final compound amount will be. 500 bracket 1 plus 0.02 to the power of 12. And I'm getting $634.12. I'm not sure what kind of calculator you're accessing at home because the pink ones are in the cupboard, locked in the school. But if you need to access an online calculator, make sure that the exponents are easily done, because there will be an exponent with every single one of your compound interest questions. You can see with this formula, it's a lot quicker to get your final amount rather than do a table that's 6 columns, 6 rows long to figure out your amount after 6 years. Okay, we're going to move on to the next question. Alice borrowed $5,000 to start a small business. The interest rate on the loan was 9% per year, compounded monthly. She's expected to repay the loan in full after 4 years. How much must she repay, and how much of that will be interest? So this is compound interest, compounded monthly. So we will need to take our interest rate of 9% and divide that by 12. And we'll have to take our term, which is 4 years, and multiply that by 12. Again, check this chart. Monthly here in the bottom column is divide by 12 for the interest rate and multiply by 12 for your term. So 0.09 divided by 12 is giving me 0.0075 for I, and my N value is going to be compounded 48 times during the length of that loan. So amount is equal to 5,000, 1 plus 0.075 to the power of 48. That amount will be, oh, I missed a 0 in here. 2 zeros, 7, 5. And I'm getting the amount to equal $7,157.03. $157 and sorry, I'm not sure what I said, 3 cents. Now, considering that she borrowed $5,000, to figure out how much of that is interest, I'm going to just subtract the 2, which means $2,157.03 is interest. So today you're just going to be practicing compound interest using your formula, using this chart here, and really pay attention carefully to the wording of the question as far as how much is it compounded by, and be very careful with your interest rate and your term.